So welcome to the talk on JUnit 5. Today we're going to talk to you about how JUnit 5 is both the new testing framework for Java and simultaneously a new testing platform for the JVM.
Yeah, a couple of words about us. I'm Marc Philipp. I work as a software engineer for LogMeIn in Karlsruhe, Germany. I've also been a consultant, trainer, and coach in my former life. I've been a JUnit maintainer since 2012, so it's still the old JUnit. I'm also JUnit's keeper of the green bar, which is a fancy title for the project lead for the last 2 years. And here's my Twitter handle, my GitHub account, and my website in case you want to reach me after the conference. A couple of words about LogMeIn. We have about 3,000 employees in 18 offices worldwide. So we're a SaaS company, so we have products like GoToMeeting or LastPass. You might know those. In the backend, where I mostly work, we do microservices, mostly with Spring Boot and Docker, and host that in the cloud using AWS. And yeah, doing DevOps.
Okay. So my name is Sam Brannen. I'm a Spring and Java consultant at a company called SwiftMind in Zurich, Switzerland. Trainer and coach, but a hardcore developer at heart. I've been a Java developer for about 20 years, a core committer for the Spring framework since 2007, once I took over the testing support, and I maintain that even today. And the main reason I'm up here today with Marc is that I'm also a core committer for JUnit 5 since October 2015. A few words about my company. We're experts in Spring Enterprise Java, Spring portfolio in general, JUnit 5 obviously now, right? Java EE, stuff like that. If you need help with code reviews and stuff like that, get in touch with us. So the agenda for today, first off, we're going to talk about the impetus for change, why we have a new version of JUnit. Then we'll dive into JUnit itself, some about the architecture, some examples. We'll have some demos and some live coding. And then I'll briefly talk about some of the integration with Spring. And at the end, hopefully we'll have time for Q&A. But if not, we have a BOF coming up later this evening, so you can follow up there as well. So first up, show of hands. Who's writing tests, I guess? Hopefully everyone. All right, who's writing unit tests? Yeah, integration tests? Okay, system tests? End-to-end tests? Fewer and fewer hands? Okay. Who's using a framework called JUnit for testing? Most people. Okay, JUnit 3, anyone? Few. Sorry, souls, okay. JUnit 4, I assume everyone, all right. 4.12, yeah, the latest and greatest? Not everybody, okay. What about JUnit Jupyter or JUnit 5? Anyone? Okay, maybe 5%, so that's not bad. Anyone using like TestEngine, something like that? A few alternatives, Spock, anything like that? Okay, so mainly JUnit 4. All right, so the question is, why do we have a new version of JUnit?
Yeah, that's a good question. So here are the reasons. First of all, JUnit 4 was released a decade ago, so it's more than 10 years old, and a lot has changed since then. We've all grown older, and the testing needs also have matured. And in particular, the expectations have grown. So JUnit sounds like unit testing, but it's actually used for more than that. And especially for integration testing, you need to have different extension mechanisms in place. And you expect that from such a framework. In terms of modularity, that's just one jar file, right? So it's, as a maintainer, it's impossible to know which part is used by an IDE or by a test author. And especially since test discovery and execution are tightly coupled, it's really hard to evolve the old JUnit. So it was really hard. In terms of extensibility, there also was a lot of room for improvement, as we'll see in a minute. And let's not forget about Java 8 and Java 9 and all the nice new language features that those will bring or have brought already. And we want to use that also in the testing framework. And JUnit 4 is still backwards compatible with Java 5. So that's one of the reasons as well. So extensibility, there's the JUnit 4 Runner API, which is very powerful. You can do almost anything, but you couldn't combine runners. So in case you want to use parameterized with the Spring Runner, well, you're out of luck. There's no way to do it. Then also in a later version, JUnit 4 introduced rules. And rules, are meant to be broken. Of course, you can read that sentence, in whichever way you would like to. So this method rule, so that wraps around the execution of a test method. But there's also a class rule annotation that lets you wrap around the execution of the whole test class. This is really great for simple use cases, like for reusing a test fixture. But and they can even be combined, and they're designed to do that actually. However, a single rule can't be used for something to do something on the method level and on the class level at the same time. And there's zero support for instance level callbacks. So for Sam here, I actually had to write two rules, Spring class rule and Spring method rule, if you wanted to use rules with Spring. And users have this awkward setup where they have to declare both of them in the test class. So that's not really great. So all these reasons brought us to having a crowdfunding campaign in 2015, initiated by Johannes Link and me. And later Matthias and Stefan and Sam here joined. It ran from July to October 2015, and we collected over 50,000 euros from almost 500 individuals and companies. And also later, 4 companies donated 6 weeks of developer time. So we had at least 6 weeks to get started. So thanks again to all the people who contributed, all the companies. That was really great support. And what we did first was then to have a whole week of kickoff meetings. And we brought together the new team, basically. So we hadn't worked together before, but also people from IDEs and build tools to get their support and their feedback, and to decide what's next for JUnit. So I hand it over to Sam. What was next for JUnit?
Good question. All right, so where we went from there, kind of the roadmap. So we started off with the prototype. We actually started on it that week, and we continued on that until December. Then we ended up releasing an alpha release the next year based on feedback from the prototype. And then we had several milestones, I think 6 in between, and then a couple of release candidates from July 2016 to August 2017. And then we had a GA release for 5.0 back in September this year, and 5.01 released in October, so last month. And right now we're working on 5.02 that should come out maybe in the next week or two, and then a first milestone for 5.1 with some new features coming out soonish as well. So what is JUnit 5 in a nutshell? It's several things. So first off, it's modular. You'll see that later on with the architecture and the diagrams, stuff like that. It's also extensible, right? So we have a new extension model, which we'll look at. We like to think it's modern. It's at least based on Java 8, so you can use stuff like Lambda expressions and stuff like that. And then another key feature that we really talked a lot about is making it both forward and backward compatible at the same time. So what does that mean? Well, we knew we had to support old versions of JUnit, new versions of JUnit, and other testing frameworks. So the platform itself now supports all of these at the same time. And new testing frameworks can also be run with the old JUnit 4 infrastructure. So for example, if your IDE or your build doesn't yet support the JUnit platform, you could use the old @run with annotation from JUnit 4 in this JUnit platform class here to actually launch the platform with JUnit 4 infrastructure. In terms of Java versions, obviously it's based on Java 8 as the baseline, but you can, of course, test application code written in another version, right? So maybe your application is written in Java 6 or Java 7, but you can write the tests on Java 8. That shouldn't be a problem. Java 9, so works fine on JDK 9. You might have heard that from Marc Reinhold, right? So we've already tested JUnit 5 on Java 9, and every artifact, in fact, has a stable automatic module name in it already, and we're adding module path scanning support coming in 5.1 in the first milestone. Java 10, can't say too much about that yet. We just started building against that last week, and we'll be waiting on some dependencies to upgrade, so they're not checking the wrong version numbers and stuff like that. Okay, so this part here is really crucial. This JUnit 5 equals the platform plus Jupyter plus Vintage. And what does that mean? I like to say there actually isn't a JUnit 5. So why are we standing here talking in front of you? JUnit 5 is actually kind of an umbrella project. And along the way, we realized that we were actually inventing kind of 3 separate entities. So first off, we have the platform released at version 1.0. And that's a foundation for launching any kind of testing framework on the JVM. And it has a launcher API and a TestEngine API for that. Also has console support, so plugin support for Gradle and Maven. And the next thing is JUnit Jupyter, and this has the number 5.0, so you might consider this JUnit 5, right? That's actually the new programming model and extension model for JUnit 5 that replaces how you would have done it in JUnit 4. And the last part we have, the last piece of the puzzle, is what we call JUnit Vintage. We thought about calling it Legacy or Retro or something like that, but basically it's the support for running JUnit 3-based tests and JUnit 4-based tests on the new platform infrastructure. So you can run all these kind of tests all at the same time and have them all reported together. So this first part, I'd like to point out again, this is basically revolutionary, right? This has never really existed before. People kind of used JUnit 4 like that, but it wasn't the goal or the plan behind the architecture of JUnit 4. And with the JUnit platform, now it is actually the idea that anyone can build upon this basis here. The next up is evolutionary, right? So kind of building on the learning experiences from Java, JUnit 4 and other things out there like Spring testing support and stuff like that. And the last part we say is necessary, right? Because we want to make sure people can continue to use their existing test bases and use it on the new platform. So this launcher API, it's used by the IDEs typically, or build tool to actually launch the framework. And it's the central API for discovering the tests, like finding the classes with test methods in them, and actually executing those tests via one or more registered test engines. And for that, we have what's known as the launcher discovery request. What that allows you to do is basically select things, like select classes, or select packages, or select individual test methods, and then also filter stuff out, right? So based on class name patterns, or tags, or engines, and stuff like that. And then in terms of getting feedback, there's a test execution listener API. So you can tie into that to basically generate your own reports if you want, but that's also how the build tools and IDEs get information about the executing test plan. And the last part here is this console launcher, so you can actually run or launch the entire platform from the command line if you want to build that in some kind of scripts. So this TestEngine API, it's kind of like the runner from JUnit 4, if you're familiar with that. It's responsible for discovering tests and executing them, but particularly for one particular programming model, so like just the JUnit Jupyter model, or just the JUnit 4 and JUnit 3 programming models, or something else. And the way these are registered, that happens automatically with the service loader mechanism from Java. So we have one for Jupyter Test Engine, so the new kind of JUnit 5 stuff. We have one for Vintage, so for JUnit 4 and JUnit 3. And you can implement your own, which people have in fact done. So there's already some third-party test engines out there. So this first one here, Spexy, supports like Scala, Groovy, and Java. Spec is for Kotlin. Got a couple others out there if you're interested in seeing what people have developed. Anyone can contribute to this wiki page, so people are actively implementing their own test engines. So let's take a look at the big picture, right? Okay, here we have the platform in the middle, right? So that's this whole JUnit platform, the new revolutionary part, and then we have the other things building on top. So we have the Vintage support up here on the upper left, and then Jupyter in the middle, and then on the right in the blue, that could be any third party that's contributing their own test engine. So as an example here, this Spexy one. And then what you program with as a developer is what you see on top, kind of the outer surface there. And what the IDEs and build tools use, they focus on the platform, and they actually don't have to know about which engines are currently present in your test plan. So looking behind the scenes, we see if you're using JUnit 4, right, you would continue to program against the JUnit 4 API, and then we have this Vintage engine that's an adapter between them. And then for the new stuff, if you want to use the new Jupyter, you would program against the Jupyter API, and the Jupyter engine would then end up finding those things and running them, and the same would be true for any other kind of test engine. And then in the middle, we see this new platform, right? So we see the launcher API, and that's what all the build tools and everything would delegate into, whether it's our runner for JUnit 4, the Surefire, support from Maven, the Gradle plugin, the console launcher, all these things interact with the launcher API. And then that, in turn, delegates to the individual engines, right, internally. So in terms of IDEs and build tools, IntelliJ has supported JUnit 5 the longest, so since 2016.2, and I think most recently 2017.2.5. So that's good. Eclipse joined a bit later, but also has very good support now in Eclipse Oxygen 4.7.1a, and we'll be seeing that in the demos. And NetBeans, I let the emoji speak for themselves. Gradle, so we have an interim solution from the JUnit team that we've written ourselves, but that's to be taken over by the Gradle team potentially by the end of this year or maybe early next year. And the same as, there's some support for Android as well. A nice gentleman in the community has contributed that. You can check that out if you're interested in that. Maven, we also have another internal solution we've written, and that's also being taken over by the Maven Surefire team. So if you want to see examples for that, we won't show this today, but you can see them in the user guide and the sample apps. Okay, so what is JUnit Jupyter?
As you said, it's basically two things. So it's an extension model and a programming model. So this is what you need to write tests. So the extension model, there's just one Marc interface called extension. And in the extension package, there's all kinds of extension APIs that extend this extension interface. And you can implement as many of those as you like. And you register them using extend with. That's kind of like run with in JUnit 4 days. But you can use it to register one or more extensions. So it's not just one. And you can put it on the interface or on the class or method level. So you can just have an extension registered for one method. That's also possible now. Or you can even use it as a meta annotation. So what extension APIs are there? The first set is what we call lifecycle callbacks. So we can do stuff before all the tests in a class or before each test in a class or immediately before or after test execution. Another one is test execution exception handler that lets you post-process exceptions or even drop them. There's execution condition, which lets you specify your own logic when you want to actually skip a test. There's test instance post-processor and parameter resolver. Those are useful for dependency injection. So the first one for fields, the latter one for parameters of methods or constructors. And there's test template invocation context provider, which is the longest name and the most complicated one of these. We use that internally for parameterized tests and repeated tests. But you could also use it to implement your own test template. We'll hear later about that, what that actually is. So this was the extension model. The programming model now lives in the JUnit Jupyter API package. And in the params package as well, and when you want to use parameterized tests, because that's in a separate artifact. It contains all the annotations, like add test and so forth. It has assertions and assumptions. Of course, you need those to write tests. It supports custom display names. The visibility, we're not as stubborn anymore. You don't have to make everything public. You just leave it as the default visibility. It supports tagging of tests, conditional test execution, and also dependency injection for constructors and methods. You can use Lambda expressions and method references with a lot of these APIs. We support interface default methods for tests and also nested test classes to allow you to structure your tests better. And there's repeated tests, parameterized tests, and dynamic tests. And this is just an overview. We'll see examples for most of these in the remainder of the talk. The annotations, there's add test, which is the one you will use most, I guess. This is actually the only one we didn't change the name for because we couldn't think of a better name. There's also test factory. That's you produce tests, which we'll see in a second. Repeated test, parameterized test, also there. Nested for inner classes. Test instance. This one lets you actually change the test instance lifecycle, configure it. So JUnit 4 also used the same lifecycle as JUnit Jupyter will by default, namely you get a fresh test instance for every test method invocation, and test instance per class lets you change that to a single test instance for the whole class. There's before all and after all, that kind of analogous to the callback interfaces, and before each and after each. There's also display name, which lets you customize or define a different display name, so not the test method. There's tag. In JUnit 4, we had categories. Tag is a bit simpler to use. Disabled is like the ignore in JUnit 4. Lets you disable tests. Rules are not actually supported by Jupyter, with a few exceptions. So we provide some migration support, as we call it. And this enable rule migration support, which comes from a separate module, and it's experimental. So it registers 3 extensions, actually. So the first one is external resource support. That lets you use all the rules that extend external resource, like temporary folder, for example. There's also verifier support, the same for verifier implementers, like error collector. So you can continue to use those for a while. And the same thing holds true for expected exception. You can continue to use it, but we would encourage you to move over to the new APIs that we provide to test for exceptions. And we had some minor bugs in there, and they're now fixed. At least in 5.02, they will be fixed, at least the one we know of. So, yeah. Of course, you need assertions, and they're now in an assertions class, so it's not called assert anymore. We provide a limited set of core assertions. Those look familiar from JUnit 4, like assert equals, assert not null. But there are also new ones, like assert throws, which actually takes a lambda, so makes use of Java 8 features. The lambda is the block of code that you expect to throw an exception, and only if it throws the correct exception, this will pass. There's also assert timeout and assert timeout preemptively that both take a block of code that you can write as a lambda expression. The first one will just check the timeout after the code is finished, so it will not stop it if it takes longer. But the second one, assert timeout preemptively, will do that. But you have to be careful a bit. If you use a framework like Spring and have thread locals, then this might break because it will execute the code in a different thread. There's also assert all. It basically takes the var args of assertions written as lambdas. So those are all checked. So imagine an integration test where you want to check multiple things at the end and want to get an aggregated report. That's what assert all is for. So it's like soft assertions in assert J, if someone knows that. We also support suppliers for failure messages. So whenever you pass a failure message, you can use a string or a supplier of string. And this message is now the last parameter in the arguments list. So we made that change because it's actually an optional argument, and that should, by convention, come last. This is meant to be only a basic set of assertions to get you started. So if you want more power, please use assert j, hemcrest, truth, whatever. Yeah. And the same holds true for assumptions, which come from the assumptions class. These are useful if you want to abort your test that has already started, like mid-flight. You can use that to define like a precondition in your test, but the test will actually be aborted, so it will be started. And if you want to really skip the test entirely, you should rather implement an execution condition extension and define that logic over there. There's assume true and assume false, kind of basic things. They take a Boolean and a string, but also a Boolean supplier and a supplier of string, if you fancy that. So you can also use that with lambdas. There's also assuming that, which takes a condition and a lambda expression, and will only execute the lambda expression in case the condition holds true. And now we'll jump into the first live coding demo, which Sam will do.
Okay, let's see how it goes. All right, so this is using Eclipse Oxygen, most recent one, right? And we've got some demo calculator here. Nothing very exciting, just want to demonstrate the testing parts, right? So it can add, subtract, multiply, divide, etc. Division could be divided by 0, right? Fibonacci could take too long, depending on which number you ask it for. So we've got an example here with, sorry, if I can get this one, the JUnit 4 one. So the way you would have done it in JUnit 4. Is that big enough to see, or should I make it bigger? Let's make it a little bigger. Okay. So we've got a calculator, subject on a test. We've got an expected exception using the rule support from JUnit 4, the same with the global timeout, and then just testing the various things like add, subtract, etc. Even support for checking for an expected exception with divide by 0, and the timeout should kick in if we make this number bigger than 40 or something like that. So if we just run this, right, it should just work. Everything passes, so that's good. That's the JUnit 4 way. So let's see if we can migrate that to JUnit Jupyter. Okay, so now pick the right one. That one, okay. So just run it again as JUnit 4, right? So we want to migrate. So what can we start off with? We can get rid of the assertions, right? Move to the new ones, and pick the one from the right package. So I should get the one from Jupyter, right? So we see at the top now, this is coming from the assertions from Jupyter, and that should still, whoops, did I miss something? Yes, I did. So why is this not passing, right? Why is this red? What did we mention about the messages? They now come at the end. Okay, so if we put that at the end, then that should actually pass, right? And we're talking about the, what if this were some kind of complex logic that we wanted to build up? What if we were actually going off and doing something else, right? 2 plus 3 equals 5. Well, if it's something that you want to or calculate dynamically, you can make it a lambda expression, and it only gets evaluated lazily if the thing actually fails. So that should also work. All right, so we've done that. We talked about visibility, right? So we should be able to get rid of some public stuff, but not on the rules, because JUnit 4 requires that. So for the methods, test methods in the class, we can get rid of public on all those, and it would start to work, except that, right, if we try to do this with JUnit 4, it's probably going to say there are no test methods found, right? So we need to switch the annotation as well, right? So going from the JUnit 4 one to the JUnit Jupyter one, pick it from the right package, and if we run that now, what happens? So the divide by 0 failed. Why is that? That's because it actually threw the exception, and we had the expected exception there, and we need to tell JUnit Jupyter to turn on this migration support. So now if we run that now, hopefully that will pass. It indeed does. So we're using the expected exception that's there. But the timeout isn't actually doing anything. So how can we actually see that, right? If we change this to something like 42 and run just this test, then we see it actually keeps running, right? It didn't time out. So it ran for more than a second, more than 1,000 milliseconds. So if we wanted to turn that on, we can basically get rid of the timeout support here. That's not supported. And we could do that the JUnit Jupyter way. So what's that one called? Anyone paying attention? Start timeout. of duration, maybe milliseconds, something like that, 1,000. And then what is the executable going to be? This is our little block of code, which we can implement as a Lambda expression. All right, so see, we got that. That's our Lambda expression. And now if we run it, what's going to happen? It still runs for more than 1,000 milliseconds, but we see that it failed, right? So this says execution, can we see that? Yes, exceeded timeout of 1,000 milliseconds by 400, right? But what if we wanted to actually kill it off early, right? If we wanted to kill it preemptively and run that in a different thread, we could do that. Switch into the preemptive one. And we'll see the difference now. So now it will run exactly a second. Oops, what happened here? So it timed out after 1,000 milliseconds, and it didn't run any longer than that. So that's what we're saying. That one gets started in a new thread. So what else can we do? We can actually get rid of the rules completely if we want to. So if we didn't want to use this rule support, and we wanted to get rid of this here, then how would we handle this exception? So this is the code of block code we want to actually execute, and we would switch that to assert throws, and the expected type is arithmetic exception dot class, right? And this can be replaced with the Lambda expression.
Not get name though. The get name has to be gone.
Thank you. That would be strange. Okay, so that should actually work now. We run this one. It does. And what if we wanted to get hold of the actual exception? We can do that. Get a hold of it. Assert equals, what are we expecting? That for exception, get message. Okay, so we have migrated from JUnit 4 to JUnit Jupyter, and we see nothing left in here from JUnit 4. So I believe that's it for that. Yeah.
Yeah, another new feature of tags. So you can declare tags on test interfaces, classes, or methods. Looks like that on a method. So we can use that to execute only a certain set of tests then from your IDE or build tool. The thing is, it uses strings and not class literals anymore. So you can't really search for references. So in case you want to, I mean, we deliberately did that so it's easier to use. But if you want to continue to search for references for tags, then you would have to use something like this. So we can actually declare tag as a meta annotation. So here we define the fast annotation and put tag on that annotation. And then we can write this code, which is equivalent to the code on the slide before. So we have a fast test with 2 annotations. We can also go one step further and compose tags. So we can declare tag as a meta annotation and combine it with other annotations from JUnit or from Spring. And that's actually possible not only for tag, but for all the annotations that come with JUnit Jupyter. So here's the fast test annotation that has tag fast and test on it. And you can then use it in your test code like add fast test. So you could define like integration tests, for example, and use that in the same way. Also, test naming has changed. So still by default, it's the test class or method name. And that's very limited, at least in Java. And we provide display name annotation, so you can actually customize the display name, which can contain spaces or special characters, even emoji. So you should use that wisely, though, right? Not all the tests should be named like emojis, but you could if you wanted. Dependency injection is also very interesting. It's one of the places where the extension model meets the programming model. So there's a parameter resolver extension API that you can implement and have implement support for resolving parameters for tests and lifecycle methods, and even constructors. You can register multiple of these simultaneously, and only one can win. So in case multiple parameter resolvers say, hey, I want to resolve this, then JUnit will throw an exception. Use cases are plenty. So you might want to inject a server URL into your test, or a data source, or a Spring application context, or a Spring Bean, for example. So that's all very useful. And also, JUnit provides some support out of the box. This test info object, you can inject that into a constructor, test, or before each method, and access the display name, tags, or the class or method of that corresponding test. And it's actually implemented using a parameter resolver internally that just happens to be activated by default. So we're eating our own dog food here as well. So if you want to have more examples, there's repetition info and test reporter in the JUnit Jupyter sources, but there's also a sample Mockito extension, and, well, of course, the Spring extension, which is part of JUnit, not of JUnit, part of Spring 5, actually. So why is that so significant, Sam?
Disabled, yeah. So some people ask, why don't we just have, like, add ignore, right?
Yeah.
Add ignore was kind of just one way. It was static, right? And so with JUnit Jupyter, we decided we'd like to be able to enable and disable programmatically, right, to make a decision about that. So that brings us to the topic of what we call conditional test execution, somewhat borrowed from the idea of profiles in Spring, if you're familiar with that. So basically, it's another place where the extension model meets the programming model, and there's an extension condition API you can implement, and then it basically decides if the test is enabled or disabled, and that's why the annotation is called disabled, right? It's static as well, but you can write your own. And if you want to see how to do that, you can check out the code for disabled condition. So this is basically a game changer, right? So it's actually very powerful. You can write your own kind of conditions for, like, disabled on a Mac, disabled on Windows, enabled only on the CI server, disabled on weekends, right? You could pick anything based on the JDK version, stuff like that. So it's quite powerful. And if you want to turn these things off, we actually have a feature for that. So maybe you had some stuff that's disabled, or for some certain reason you want to just see if those tests should actually pass in the current environment, then you can actually deactivate those via the launcher with system property or in the JUnit Platform properties file. And that's via a key named JUnit conditions deactivate, and accepts a pattern. So you can turn off all the JUnit conditions or any conditions you've written in your company, or Spring conditions or stuff like that. So now we will take a look at these things in turn: tags, display names, dependency injection, and conditions. So we have a class with a gigantic name, fast test and a normal test. Well, how do we make them tests? Right, pick the right annotation. Right, so that would make them just run as is. Right, we should see 2 out of 2, that's good. But what if we want to make those in fast, right? So we would say something like tag. Right, pick it, the right one, say fast. And the other one maybe is normal. So now we still see 2 out of 2. That looks very strange. What happened there? It looks like my Eclipse is having a problem. It says it ran 2 out of 2.
That's filter that's on, or over there? No,
No,
not this one.
oh,
This one.
Yeah. How did I click there? Okay, so it's showing both, right? They're both there. They're both running. So what if you want to filter based on that? Well, Eclipse has support for that. I'm not sure if IntelliJ has it yet, but you can go to Run Configurations in Eclipse Oxygen, click on the Configure for Include and Exclude tags, exclude everything that's tagged with fast, apply it and run it, and now we'll see that we have only one, right? So it doesn't even show up in the results. So that's the tagging in action. And we mentioned as well that you could have a custom annotation, something like fast test. And let's just take a look at that. It's the same as from the slides, but basically it's used on methods, retained at runtime, and it combines fast tag and test together. So if we rerun this test again, we'll see the results are the same, that the fast test does not show up, only the normal test actually got executed. So that's how you can have stuff like integration test, smoke test, fast test, and stuff like that. And you can combine multiple tags and also combine that with stuff like Spring with @transactional and stuff like that. So that's the tagging part. And the display names. So we mentioned, right, by default, it just picks fast test display name. We could say something like fast test, something like that, right? And we could go back and make sure we pick this, turn that exclusion off again. So we want it to actually run now. Apply and run. And now we'll see something different. So now it says fast test, right? And that it can have any kind of special characters you want. And this is the super cool feature that everyone loves. So you can't type an emoji in Eclipse, but you can copy and paste them into Eclipse. So now I have one, and if I run that, what's going to happen? Yes, that's right. It shows the emoji. Yay. And you can even double-click, and it goes straight to the method. So that works the way you'd expect. Just to show you, that's working with the build as well. So if we were to run the test from the command line using the Gradle plugin, we should hopefully see an emoji spit out somewhere. And some tests are expected to fail, but we should see, there you go. So even the emoji shows up in the test results on your CI server and stuff like that. So we don't recommend it, actually, maybe for something like locales with flags and stuff like that, but maybe not the poop emoji or anything like that. All right, so that's custom display names. You can do it at the method level. You can do it at the class level, right? So you could say demos, right? And if we run the whole thing, we see even the class gets a custom name. So demos, fast tests, etc. And what if we wanted to access this stuff? So we're talking about dependency injection. There's this thing called test info, which basically replaces, what is it, test name? The test name rule from JUnit 4, right?
Yes.
Right, so you could say test info, and I'm just going to be lazy and print this thing out. It has a super nice toString, which will print all the information for us. So now if we run just this test here, we should see some stuff. The console, so the display name is listed there. Any of the tags that were there are listed out. The actual test class is there, and the test method. So you can access that stuff if you want to do something programmatically based on that, or if you want to just log it or something like that, that's an option. So what's left is conditions. So what if you wanted to disable the normal test? Like right now, if we run it, we see 2 of 2 should be, right? So the normal test is running as well. And if we just wanted to disable it for some reason, we could say disabled. And now if we run them, we'll see that it actually gets skipped completely, right? So in the IDE, it probably shows you something like this little gray icon, 2 of 2, but 1 was skipped. And this other conditional stuff, so there's this other thing I'm just going to talk about briefly now. Like I was saying, anyone can build on these conditions. This disabled on Mac comes from the Spring support that I authored for Spring 5, and it has a disabled if annotation, which builds on the JUnit Jupyter support, but supports Spring's spell expression. So any kind of dynamic expressions built in line, very powerful in Spring. So we're checking the system property, OS name. If it contains Mac, then this thing should be disabled on a Mac. So if I now run this test class again, then we should see that in fact that one is disabled because it's on a Mac. So that's very powerful, and you can do anything like that on your own as well. Okay. So yeah, testing traits. What are testing traits? Like Java doesn't really have traits, right?
Not really, no.
So,
but they have interface default methods now. So that's kind of, yeah, what you can call testing traits. So we support interface default methods, and this kind of enables the concept of a test interface. So you can inherit from multiple of these interfaces and define tests as interface default methods. So we actually inherit like testing traits. And we support also before all and after all on these interface default methods, but they have to be non-static, and in order for that you have to use test instance per lifecycle, per class, sorry. Before each and after each are supported without any changes. Also the other test annotations, tag, extend with, and we'll actually look at some example right now. So the string test, let me put that here. So this is an example. I will run it first. As you can see, there were six tests that were executed. And yeah, so, but there are actually no tests in this test class, right? But it implements 2 interfaces. One is called comparable contract, and the other one equals contract. So when you go there, you will see that there are actually default methods in here that are annotated with test. And in this case, this is kind of the contract for the comparable interface. So that's one way you could use this for. Or the equals contract also has tests. And they have some abstract methods, of course. You need have some concrete values. And yeah, these are implemented here in the string tests class. So this is kind of a new way you could use this for testing. And this would not have been possible without support for Java 8. All right. Yeah, we've seen all that. Yeah, next up, nested test classes that enable you to have logical hierarchical grouping of test classes. So you can actually share initialization and state from outer test classes into the nested class. You have to declare nested this annotation on your non-static nested classes, also known as inner classes. And you can even combine nested classes and these test interfaces. So that's all perfectly composable. And we'll look at the testing a stack example, so we get some better feel for this. So this is quite an elaborate example. We run this first and expand all here. So this also uses display name. Oops. Where did it go, Sam? Ah, here, found it. Yeah, meant to scroll. Zoom. So we actually have a stack, and they use display name, so it's readable like a stack. When you, after pushing an element, it is no longer empty, right? And when you look at the implementation for that, this is actually the outer test class, a stack, and has an inner class, when you, and each of these things has a before each method. So that's, the stack is actually declared in the outer class, and then initialized here, and then used throughout the nested test classes. So you can have grouping for your tests, but also share the common setup for a group of tests. Yep. So we mentioned test templates previously. Can you tell us something about those?
Yes, so a test template is basically like a test method that serves as a template that can be invoked multiple times in different ways. So like first up, we have repeated tests. If you want to invoke the same thing just multiple times, basically just annotate a method with @repeatedTest instead of @test, and then specify the number of repetitions. And you can optionally have the repetition info injected into it to get access to the current repetition or the total repetitions and stuff like that. You can also optionally override the display name. So seeing that in action, it would look something like this. Here we have the first one here, repeated test 5, and getting access to the repetition info. So we're seeing that the total repetitions is 5, just for an example here. And the next one we see how you can actually have custom names with placeholders in there. So if you wanted to translate into German or some other language, for example, here we're saying this is the same as repetition 1 of 5 or Wiederholung 1 von 5, something like that. So you could do that as well. The next thing we have support for with templates is much more powerful. One of the most powerful features in JUnit Jupyter. So that's parameterized tests. And you just annotate a method with @parameterized test instead of test, and specify the source of the arguments, where they should come from. So you can also optionally override the display name like with repeated tests. And in terms of sources, we got lots of options there. So value source, just for some scalar values like strings and longs and doubles. Enum source to pull out constants from an enum, even based on ranges and patterns and stuff like that. Method source is the most powerful one. That's where you can have JUnit invoke your own factory method to provide the parameters for your parameterized test. We also have support for constipated values, either inlined as strings or actually pulled from a file in the class path. So it's also a nice option. And if none of those meet your needs, you can configure your own argument source and a custom argument provider, pulling your data from wherever you want, maybe from a database or some other type of file and stuff like that. In terms of the argument conversion, we have some built-in support for that. There's implicit conversion for the basic types, primitives and their wrappers and stuff like that. Also for enum constants and types from Java time, like local date and things like that. But there's also explicit conversion support if you need to implement that. So you can use the @convert_with annotation on a particular parameter and implement your own argument converter where you know how to convert into the target type. But we also have some built-in support for Java time conversion pattern, so you can define a pattern if it doesn't align with the default pattern that we use. So what that looks like, again, just put @parameterized test on a method like this, and then specify something like value source. So here we're specifying a list of strings. Here, some candidates for things that should be palindromes, so you can read them forward and backward. And then each one of those gets passed in individually. So this would get invoked 5 times with each of those strings, and they would actually show up as individual tests, right? So we can use that to parameterize. So let's just see those executing in action so it hits home a little better. All right, so we've got from here, we have, if I can find that one, working, repeated tests. So this is the example we saw before, repeated tests with the repetitions, and here the translation. And if we execute that, then we should see those all show up. All right, so expand all, and now we can see that we do indeed have those. So each one of those gets displayed underneath that template method that serves as a container for all of these invocations. And the same is true for a parameterized test. So if we were to look at those, this example here commented out with the value source and demonstrating how to do it with the method source. So you just name the method. Here, candidates, static method, and this is a factory method for your arguments, and here we're just returning a stream of those same values. So if we were to run this test here, we would see that the results are similar. So again, as the container is the method, and then we see all the invocations with the default display names for a parameterized test. So the invocation count plus the arguments, all of the arguments that were passed in to that method. Okay. So we've seen how we can use lambdas for things like assertions, but how can we use a lambda as a test? Is that possible?
Of course.
Of course.
Yeah, so we have dynamic tests. So why is this called dynamic? Conventional tests are static in a sense, so you know all the test methods once you compile the test class, right? A dynamic test, on the other hand, is registered at runtime, so it doesn't exist at compile time. At least not, well, in code, but not really. So it's a Lambda expression that you can return as a stream of dynamic tests, and by a method that is annotated with test factory instead of test, because it produces tests. You can also use dynamic containers if you want to have some structure in there, some nesting again. It's somewhat analogous to parameterized tests, but just more dynamic in a sense. So let's look at some example. Here is a method that's a test factory method and returns a stream of dynamic tests. And we started off by using an in-stream to iterate over all even numbers, then limit it to 10. And for each of these numbers, we map the integer to a dynamic test using a static factory method here that takes the test name as its first parameter and a lambda as, well, the test body, basically. So this is what you would normally write in a test method body. Yeah, let's look at the source code in Eclipse. So we have dynamic tests here. Oh, we wrote those extensions here. Well, anyway. Okay. Yeah, we have a method here. And this is the same method from the slides. And I'm just going to run it. Yeah, don't mind that right now. So you can see we have first 10 even integers as a method. And there's basically one test for every even number. Yeah, for the first 10 even numbers. Because we limited it to 10 right here. And yeah, so the name is built from the test string and the number. And again, this is like one assertion is the only test. So let me change that to make it fail quickly. And run it again. Yes, I want to save that. Okay, I just ran more. But you can see 5 tests have failed now. And basically, I made it so that I tested that all even numbers are divisible by 4, which is of course not wrong. Not correct, sorry. So 2 fails, right, and 6 fails, for example. So that's how you would use dynamic tests. And you can use lambdas now to write tests. Basically, you can write any code in this test factory method, and you could load the data from anywhere, again, from a database or from some file, or generate some random data even. That's all perfectly possible now. So what's missing? Yeah, we don't have scenario tests yet, which is what we call tests where you have dependencies. So imagine a UI test that logs into a website and browses up to some page and logs out again in the end, where you would like to formulate these steps or specify these steps as individual test methods, but then have them executed in the correct order, of course, and maybe even share state between those. So we have that on the roadmap still, and we'll work on that. Hopefully soon. There's also ordering of test methods and of extensions as well, which we don't right now have. Parallel execution as well. Execution in a user-defined thread is something that's missing. Declarative and programmatic test suites for the JUnit Platform. We actually have a runner, the JUnit Platform runner that Sam mentioned previously, that you can use to declare a test suite, but that uses the JUnit 4 to run it and not the platform directly. So that's kind of strange, and we want to have first-class support for that. And also Java 9 module path scanning is something we are currently already working on, and this will be added soon. So we'll skip this live coding demo, I guess.
Yep.
And maybe if we have some time at the BOF, do it then.
I think so, yeah. So the same for Spring. I'll just mention briefly that there is full support for JUnit Jupyter in Spring 5, supporting all the core features and Spring testing support. Also support for dependency injection for test methods and stuff like that. Already showed the disabled if stuff like that. But it also works with Spring 4.3 if you use my project here on GitHub. So we can look into some of these things during the BOF and show some more demos for how to actually implement some extensions. So in closing, these slides will be made available online. We have links to JUnit resources and Spring resources, and all the code that we've used so far is available in my GitHub repository. So in 20 minutes, you can come join us. BOF room number 2. We'll be there for an hour, and we'll be there to answer questions and demo anything that anyone wants to see. So thank you very much for coming.
Yeah, thank you.